solve the problem from LeetCode 75. We have already solved all these problems. The first problem from all these topics. So this is we have solved from array, strings, 2 pointers, sliding window, prefix sum, heap map. So these problems we have solved. Queue, linked list, binary tree, TF. So we have solved all the first problem of these topics. Now we are going to solve the first problem from binary tree. BFS. So BFS means build first search, right? So the question is a right side view of binary search tree. We have given a root. So and we have to print the right view of the BFS, right? Okay. Okay. Cool. So as you can see in this picture, this is a tree, right? And we have to print the rightmost node of tree at any level, right? So at particular level, let's say this third level, the rightmost node is 4, so we have to print 4. At root, the 1 is the rightmost node. At level 1, 3 is the rightmost node. At level this 4 is the rightmost node, and at this level 5 is the rightmost node, right? So how can we solve this problem? So we can solve this using BFS, which is BREATH width. SEARCH, right? What you can do is make a queue, insert root, second at any level, root, and process with the levels, right? So let's see how can we do this. Okay, so let's say we have to input this. Okay, so we are making a queue. Queue is empty right now. We will insert root, so queue is inserted with 1. Okay, now and we will also insert let's say end, something like this. Okay, so this means this is the end of the level, because at root there is only one node. Now we will iterate through this queue until we reach the end. Okay, so we will end, what we'll do is we will append the left and then the right of this root of this node, of any node which is present in the queue. So after that operation, and okay, so we will so at any level we will print the rightmost element before end. Okay, so we will print 1 here. After that we will pop 1 and check what is in the right of 1 and what is in the left of 1, and then we will append what is the right of 1. So in the left there is 2, so this node, and in the right there is 3. Okay, and we reach end, so we will append end. So in this level, in this queue, the rightmost is 3, so we'll print 3. So now we will check, we will pop out 2 and check what is in the left. So left is nothing, so we will ignore. What is in the right? So right has 5, so we will append 5. Now we will pop 3 and check what is in the left. Left has nothing. What is in the right? Right has 4, so we will append 4 and we will append end. So from this level, what you can see is there is a 4 in the rightmost side of this queue. So we will print 4. So the answer, and now we will go again. We will pop 5. What is in the right? Nothing. What is in the left? Nothing. So we will ignore. But then we will pop 4. What is in the right? Nothing. What is in the left? Nothing. So we will ignore. Then we have reached end. If the queue is empty, so we will not append end also, and we will return. So what is the answer? 1, 3 and 4. So the answer is 1, 3 and 4. So let's check with this again. Okay, so the root is sorry guys. Sorry. Now we will make queue, we will append root and now what is this will return, this will print 1. Now we will pop q and we'll check what is in the left has 2, what is in the right has 3, and we will reach end. So and this will print 3. Now we will pop 2, we will check what is in the left has 4, what is in the right, nothing. What is in the right, nothing. So we will ignore. Now we will pop 3. So what is in the left, nothing. What is in the right, nothing. So we will ignore. We will append end as our queue is not empty yet, and the rightmost element is 4. We will pop 4 and check what is in the right, what is in the left. 5. What is in the right, nothing. So we will append end, and we will see that the rightmost element is 5. Now we will pop 5 and there is nothing in the left and the right, and we will return, right? So the answer is 1, 3, 4, 5. So answer is 1, 3, 4, 5. So guys, so I think you understand my this approach. So insert root and process the labels with any label. Get the rightmost element and from the queue. Okay, so that is what we need to do. Now make a queue. Q U E equals to, so we are making a list. Okay, now temp is equals to root. So we have given a root. Okay, while so temp is equals to root. No. Q. So we'll make a q dot append root, q dot append none, while not, so while length of q is greater than 0, something as q. So while length of q is greater than 0. Okay, so what you can see is just the element just for end is we need to return, right? So we will see previous equals to -1, answer equals to we have to return a list, so answer is equals to empty array. So top is equals to q dot pop 0. Okay, now previous equals to top if top equals to none, right? Q dot if then equals to 0, if length of q is not equals to 0, q dot append none. So as we have reached the end, we will append end again. Okay, now if top is equals to none, right, answer dot append previous. So we will append the previous element to the answer. Okay, good. Else if top is not equals to null, right, so previous will become top dot value, if top dot left, if top dot left is not equals to null, q dot append top dot left, if top dot right, top dot right is not equals to null, q dot append top dot right. Okay, so that's all we need to do, and we will return answer. Okay, is not equals to 0. Okay. Print q. Okay guys, sorry. So if not root, right, if not root, if root is equals to none, return none, which is nothing. So we will return either 0 or none, right? So output is null. Okay, so we will return empty array. So yeah guys, as you can see, we have solved this problem. We have all the test cases getting passed. So yeah guys, as you can see, we have solved this problem, but the time complexity is, I think, very high. So let's see the best case. It is this script dq. Guys, as you can see, they are also using a QLI approach, in which they are making a label size. That's all we are doing. Just we are using a smarter solution, but time complexity wise, this is a very good solution. But we are also doing we are also solving this problem in a very efficient manner. It's just a matter of few milliseconds. So this will not be a very we should not highly worry about this. So these guys are also doing similar thing. They are just using they are counting the length of the label, and they are iterating through that length only. So that is what they are doing. We are doing in a different manner, but not very different. We are doing with taking a none as a identifier that we have completed our level iteration. So that's all, guys. I think you this is a kind of a different approach from this, but not very different. We are using queue, we are using uh, iteration, and we are using BFS. So I think this is a kind of a similar solution, but a little variation. So this is also a very good solution. So I think you understand my approach. If you have any query, if you have any question, you can ask in the comment section. uh, that's all from me. Thank you, guys. Thank you.